I'm a graduate student at UC Berkeley, advised by Jacob Steinhardt. We've been working on getting AI systems to forecast future events at a level more accurate than expert human forecasters. In our work, we find that our system approaches the expert level and in some cases surpasses it. And I'm really excited to share this work with you all today. And yeah, I worked with some great collaborators, Fred Zhang, Yuhan Chen, and my advisor, Jacob. Let's first talk about what I mean when I say forecasting. So in this work, we study judgmental forecasting. Here, forecasters assign probabilities to future events based on their own judgments. To do this, they usually make use of whatever historical data is available, their domain knowledge, Fermi estimates, and a lot of the time, just their own intuition. This notably differs from time series forecasting, which uses tools from time series models, which works well when the data is abundant and under minimal distributional shift. So, for example, if you're forecasting the weather, you would typically use a time series model, and this would be in the domain of time series forecasting. But if you're trying to forecast something specific with minimal historical data, like will AI doctors replace humans? Now we're in the field of judgmental forecasting, which is the focus of our work. Yeah, so just some example questions. Will AI doctors replace human doctors by the end of 2030? Will a nuclear weapon be detonated in 2024? Who will have de facto power in Gaza Strip on January 1st, 2025? And if there are any questions throughout, please feel free to ask in the chat. So why do we care about this? Well, accurately predicting the future is very valuable. Just as some brief evidence, governments rely on economic and geopolitical forecasts for decision making. Companies hire invest based on forecasts of market conditions. And in 2020, epidemiological forecasts for COVID prompted national lockdowns across the globe. Forecasting has some important implications. Why do we think it's a good idea to use language models for forecasting? In particular, what advantages might they have over human forecasters? Well, as you know, they can parse and produce text rapidly. So this can provide cheap and timely forecasts. They are pre-trained on web scale data, so they have massive cross-domain knowledge. We can elicit their reasonings through prompts, which allows us to understand at least partially the rationale behind the forecast. And their knowledge is up to a specific date. So if you take a look at GPT-4, it was trained up into some certain date and then released. This allows us to train and test them on events that actually have already been resolved in a way we can't do with humans, since their knowledge only goes up to some date. So now I'll talk about the task and the setup in a bit more detail. What we do is we source binary questions from 5 competitive forecasting platforms. Here's an example to illustrate what these questions and their metadata look like. So the question here is, will Starship achieve liftoff before Monday, May 1st, 2023? This question comes from the forecasting platform Metaculus. Each question has an open date, which is the date when forecasters can begin to make predictions. There's a closed date, which is the date when forecasters can no longer submit predictions. And there's a resolve date, which is the date when the question either resolves as yes or no. In this example, the crowd prediction was as high as 0.79 in April the 17th of 2023, and as low as 0.69. And the question ultimately resolved as yes. So these community predictions are just a bunch of people who submit predictions. And then when you see this individual prediction on this date, this is the aggregate of all the individual human predictions into one probability. So how are we going to set this up? So the way this will look is we'll allow the system to retrieve some information and then have it submit a prediction. Yeah, so we take a forecasting question that was posed after the pre-training cutoff of a language model. And then for these questions, we take a date between the open and closed date, which is called the retrieval date. This is the date that will source information up to. We won't allow the language model to source any information beyond this retrieval date. Step 2 would be retrieving information up to the retrieval date. Step 3, we're going to feed the information retrieved and prompt the language model to make a prediction. And then we're going to compute the performance using the Breer score, which is just the prediction minus the actual outcome squared. And then we'll compare, our system's Breer score to the Breer score of the crowd prediction on that retrieval date. Cool. So our training set consists of questions before June 1st, 2023, and our test set consists of questions after June 1st, 2023. This is important because after June 1st, 2023, the language models that we use have no knowledge of the world. They weren't trained on any data beyond that date. Some sample questions from our data set. Will Russia successfully land on the moon in August 2023? Will there be a case of Marburg virus in Algeria by July 28th? Will Tesla's market cap be greater than 1 trillion before July 1st, 2023? And our questions mention a diverse set of locations, which I think is really nice. As you can see from this map, these are all the locations mentioned in our questions in our data set. I think it's best, it's easiest to see how the task works as well as our system through an example. So I'll walk us through that. So for an example, here's a question from our data set. Will Humza Yousaf be the winner of the leadership race for the next First Minister of the Scottish Parliament? So this question opened on March of the 1st, it closed on March of the 26th, and it resolved on the 27th. The background here is Nicola Sturgeon stated her intention to step down from the role of First Minister of Scotland. There are three candidates in the running: Kate Forbes, Ash Regan, and Humza Yousaf. And the question will resolve is yes if Humza Yousaf wins the leadership race. So what we've done is we've chosen some retrieval date that is between the open and close date, and we're going to retrieve any articles that were published before this date and give them to a language model. The first part is retrieval. So first we start with a question, which is, will Humza Yousaf be the winner of the leadership race? Then we're going to come up with some search queries to search for information relevant to the question. We're going to use a news API to feed the search queries to, like Google News or Newscatcher. Then we're going to retrieve a set of articles. And lastly, we're going to ask a language model to rate the relevance of the article with respect to the question. And then we'll take the articles that are most relevant and give it to a language model to summarize. So at the very end, we hope to get a set of summarized articles that have information relevant to the question. Okay, so let's see how this works. So here I've summarized the prompts that we actually use, but I've attached the actual output in this case. Here we just asked the language model, generate brief search queries to gather information on Google that could influence this forecast. So the model outputted, okay, Humza Yousaf leadership race odds, the candidates, what do people predict, and election updates. So it seems like some pretty reasonable things to look at if you're trying to predict the election outcome. And then what we notice is this doesn't actually provide the most coverage of all the considerations possible. It's with this technique, you're really just getting information that's directly relevant to the question, but oftentimes you want to consider other things that are not directly relevant. For example, if you're trying to forecast an election, you might consider the state of the economy. You might consider if there's any, scandals going on. You might consider how much funding his party has, etc. So we tell the language model in this case to write down sub-questions that would help, which if answered could help, improve the accuracy of the forecast. So we tell it to write down some sub-questions to help steer the search queries. So here the sub-questions are like, who are his competitors? What do the polls say? Are there any scandals or controversies? What are the opinion of his party of him? How does his platform compare to his competitor? And what endorsements has he received? Once we have these search queries, what we can do is basically use a news API to try to gather articles with respect to the query. And once we gather articles, we ask a language model to rate the relevancy of the article from 1 to 6, given some criteria, where 6 would be the most relevant, 1 would be least relevant. So here the model says the article provides some information. The information is directly relevant. It gives it a rating of 5. So once we've deemed that the article is relevant, we're going to ask the language model to summarize it. So here the prompt might be, condense the article to 100 words, keep information that's relevant to the question. And here it tries to, keep the most salient details that are relevant to the forecasting question. So now at this point, we've gotten a set of summarized articles that are relevant to the question up until some date, which is what we retrieved on. And now we want to actually use these articles in tandem with the language model's pre-trained knowledge and reasoning capabilities to make a prediction. Given the question and the news summaries, we're going to prompt 2 language models. One is Base GPT-4, which we give the question and news summaries along with some scratch pads to provide guidance on how to think about these questions to Base GPT-4. And then the other language model that we prompt is Fine-Tune GPT-4, which doesn't require any instruction. We just give it the question and the summaries, and it itself it has learned which sort of reasonings to use in which context. So it's learned to use a certain type of reasoning when, forecasting elections, and different types of reasonings when forecasting maybe market outcomes. And then each of these language models generates a reasoning and then a final prediction. And then we aggregate the final prediction into a forecast. So yeah, I'll continue with this example so you all can see what it looks like. Here is just prompting base GPT-4. This is the output of base GPT-4 after we prompted it. So first, it just rephrased and expanded the question. The point of doing this is just to make sure the language model understands the question, as well as it's able to now contextualize the question with its own knowledge that it gained during pre-training. Then it gives considerations why the answers might be no, and it gives a strength for each consideration, and it does the same for yes. It aggregates the considerations and outputs an initial probability, and then finally it assesses whether its initial probability is too high or too low based on its confidence level, historical rates, and other things that are provided either through the articles or that it's learned in the past. And then it gives a final prediction. So in this case, the prediction that it gave was 0.55, and the crowd prediction gave a prediction of 0.52, and the outcome was 1, meaning he did get elected. So fine-tuned GPT-4 did, invoked a very different type of reasoning. Here we told it to follow. So for base GPT-4, we told it to follow this exact structure, meaning we told it, to first rephrase and expand the question, to consider reasons why it might not be, what might be no, why might be yes. But with our fine-tuned GPT-4, we just gave it the question and said, reason about it however you want to. And in this case, it wanted to use a decision tree outline. So it considers different scenarios where he could win, and it considers different scenarios where he could lose, and it puts a probability on each one of those scenarios. And then it discusses, wild cards, things that could happen that could influence this. And then it does a branch probability analysis. And in this case, it outputted something a little bit more confident, which was 0.6. So we basically prompt GPT-4 3 times, and we prompt fine-tune GPT-4 3 times. And then the final prediction is the trim mean of the 6 forecasts. The reason why we prompt GPT-4, both models 3 times rather than just once, is because in forecasting, often if you elicit multiple predictions and then you aggregate, this often is stronger than just any individual's forecast. Earlier, I talked about prompting a fine-tuned GPT-4. So yeah, just want to talk a little bit about how we fine-tune this model. So to do this, we take forecasting questions in our training set, and then we actually run our system with base GPT-4 end to end. So what this means is that we take a forecasting question, we generate summaries, we prompt GPT-4 with scratch pads to generate reasonings and predictions. Which gives us a huge list of candidate reasonings and predictions. And then we keep the ones that are accurate. So if GPT-4 generated a prediction that was more accurate than the crowd prediction, we keep that reasoning and prediction, and we use that for downstream fine-tuning. So the fine-tuning data would just be the question, the description, the resolution criteria, the article summaries, and there's no instructions here in the input. And the output is just the reasoning and the average of the model's prediction with the crowd prediction. And here, by removing the instructions, the model learns what type of reasoning to use in which context. That's basically how our system works. And now I'm going to talk about how it fares. So we sourced questions from five platforms. In total, we have 914 questions. All the questions are published after June 1st, which is after all the language models pre-training cutoffs. And we use 5 retrieval dates. So basically, for any given question, we're going to source articles up until 5 dates. And we're going to compare the performance of our system to the community on those retrieval dates. The Breer score, which is the metric I talked about earlier, their standard metric in forecasting, which is just the prediction minus the outcome squared, where lower is better in this case. Our system achieves 0.179, where the crowd achieves 0.149. So there's been some work done in this space compared to prior work when looking at just total accuracy, since that's the metrics that prior works use. Our system achieves 71.5%, where the crowd achieves 77%. So you can see a 6%, about a 5.5% delta, versus in prior work, one pretty recent actually still had a 20 percent plus deficit with the crowd. So you know, on for prior works, they were actually using even easier forecasting questions, and there was this huge deficit. For us, we were using very maybe perhaps more difficult forecasting questions, but we still sort of narrowed that distance. So now I'll talk about some like behavioral aspects of our system. So one thing that we noticed is that as you're able to source more articles for the question, our performance essentially improves. So here with the Breer score, if the score decreases, you're doing better. And when you can only retrieve up to 5 relevant articles, you could see that the gap between the crowd and us is pretty big. But the minute you can source more than 5 articles, this gap decreases. Another really interesting thing is that if you look at the distribution of the predictions of our system versus the distribution of the predictions of the crowd has this, large left tail, whereas we don't. And what you can take away from this is that there are some questions that are just obviously no, that the crowd is saying, okay, less than 5% chance of happening, where our system doesn't sort of report that same statistic. And one reason why is because we're using GPT-4 in our system, which has safety training. And so the system might not want to give you definitive probabilities. So like, you can imagine that if you have a safe system, you really want to hedge as much as you can and say, oh, it might happen, it might not. And so through fine tuning GPT-4, we've, sort of like erase this feature, but it still persists to some level. And then if you look at the performance over the retrieval date, so this is like retrieving articles for the up until the first date, the second date, third date, fourth date, fifth date, our score starts off better than the crowd. But as you approach closer to the resolve date, the crowd actually does much better than us. So it seems that we're better at predicting when the question is just released. So imagine you have a forecasting question. It was released, the first, 3 forecasting dates, we did much better than the crowd. And the last 2 forecasting dates, which is like when the question is very close to resolution, the crowd did better. And it's probably due for the same reason as this example here I just described, which is that in the beginning there's a lot of uncertainty, and our system is pretty good at predicting in term when there's high uncertainty. But as the question, as the resolution becomes more clear, our system doesn't want to report decisive probability, but the crowd does and ends up being more accurate in that case. Those are sort of the main reasons why we see this difference. Like, what would happen if we just like took those situations where our system does really good? So, in the real world, a forecaster doesn't have to like forecast on every question. Like, typically, forecasters just forecast on questions that they have expertise in. Maybe it's a convenient time for them. Maybe they're feeling confident that day, right? So they don't have to forecast all the time. So let's say we take the same approach, which is we only forecast in situations where we think our system is going to excel. The first situation would be if there's more than 5+ retrieved relevant articles, this would be a favorable situation for our system. If it's on an earlier retrieval date, meaning, shortly after the question is opened, we see that our system is generally better. And on top of that, when the crowd is uncertain, meaning there are probabilities between 0.3 and 0.7, we also think that our system, can do pretty well in this scenario. When we look at when we forecast on questions that jointly meet these 3 situations, our system achieves a score of 0.237, whereas 0.240, where the crowd achieves a score of 0.247. So we're doing actually better than expert humans in this case. And one interesting thing is if you average our prediction with their prediction, you get a score that is even better than the individual ones. So, I mean, this shows that language models in tandem with humans can actually get something better than any of the individual components, which is quite a good result. One thing here that might stick out is like, okay, maybe your performance like is completely the result of using GPT-4. Like maybe this like retrieval component of your system isn't really that strong. Maybe like your fine tuning isn't that strong. Maybe your reasoning system isn't that strong. It's really just because of GPT-4, which I think is a very reasonable thing to think. So what we did is we tried using weaker models like fine-tuning GPT 3.5, and we see our full system was 0.179, whereas which in our full system with fine-tuned GPT 3.5 was 0.183, so it's only slightly worse. So GPT-4 is definitely a component here, but it's not like, the entire the performance doesn't hinge on GPT-4 entirely. And then one other thing we want to ask is like, okay, if we took away the retrieval part, which is like you can't retrieve any information about the forecasting question, if you can't fine tune GPT-4 and you just have to prompt the base model, how well would this do? And it turns out that it would do, significantly worse. Yeah, I think these ablations demonstrate that when you have this full system that can, source information really well, combined with this fine-tuned model, you can actually get some performance that's pretty competitive. Just some concluding remarks. Forecasting is a strong benchmark for language model capabilities. Currently, this is not a benchmark we see like evaluated when a new huge model is released. Like it's not like MMLU or math, but it's a really interesting and benchmark and a good one because the model needs to synthesize information, both from live and pre-training knowledge. It needs to reason and then it needs to remain calibrated. These are all very difficult things to do. And when thinking about like, okay, what language model is the best? Is it GPT-4? Is it Claude 3? I think it would be nice to see forecasting added as a language model benchmark because it's quite a difficult task and it involves like a lot of different capabilities that need to be done correctly. There's also lots of data in the wild. So we source forecasting questions from prediction platforms, but I mean, anything can really be a forecasting question. You could take a sports game that already happened and you could ask a model that, was trained up until a date before that game and say like, here's an upcoming game. Who do you think is going to win? Same with the stock market, same with any historical events. And one neat idea is you could take a newer LLM that has knowledge up into the world recently and tell it to come up with questions that older language models don't know. So you can train those older language models on those questions. And I think forecasting is really important for safety. You can imagine that as AI becomes really capable, it becomes very difficult to understand what's going on in the AI space. And if that ever happens, it might be useful to use AI to actually forecast AI capabilities and behaviors. Yeah, so that's what I have today. Happy to take questions.
Neerj has a few questions he posted in the chat. Actually, one of his questions similar to what I had in mind. Did you guys try other models than OpenAI GPT, for example, open source models? And that gives more flexibility to you, right?
Yeah, absolutely. So we did try a lot of open source models. So which is reported in the paper, but not in this presentation. But what we found is that the only open source or okay, so no open source model is competitive with any of the closed source large models. The best one that we found was Mistral 7B, but it trailed the performance of GPT-4 quite significantly. But other models that did just as well as GPT-4 would be, Claude 2. That one did really well. Claude 3 recently came out, and we are actually pretty excited to try it out.
Do you think there's a future for open source models? I mean, it seems like they're lacking right now, right? But they give so much flexibility for research and opportunity for the community. Do you think there's a chance that they will catch up?
It's an interesting question. I personally, if I had to bet on it, I think they are going to catch up. I think there's enough really strong organizations working on open source models. I mean, for example, I think Meta is due to put out a new model. I suspect that, Llama 2 was really good at the time when it was released. Now it's not as strong, but I anticipate that if, they release another model, perhaps, it could compete with the current closed source models. Yeah, I mean, even if it doesn't happen in the next year or so, like there is a lot of incentive for an organization to create an open source model that is just as strong. Because then people would really want to use that instead of like having to go through OpenAI. So yeah, I think there's a world for it. I think some Yeah, I think some companies, are also a little bit apprehensive about releasing really capable models. You can imagine that, a couple years when, we have GPT-7 or whatever, and it's really, really capable, making that open source is not necessarily like clear from a safety perspective. Like, can this be used in a harmful way? So I think that those are some considerations that people are sort of thinking through right now, and it's a little bit challenging.
Neeraj, do you want to ask your other question?
When you talked about, how you pulled data and scored the data from the news API, you mentioned relevance, right? You scored the articles based on their relevance to the question.
That's
I'm
right.
curious about veracity. How do you guarantee that the articles are accurate in some sense? And also, like in the scratch pads,
Yeah.
I'd love to see an example of a prompt. Like, how do you have the base GPT model take into account like the relevance score when it's or is that not is that are they already filtered out like previously in the pipeline?
As far as veracity, base GPT, so when we prompt base GPT-4 with the articles, we include the article source, like, who published it. We include the date, the author of the article. And base GPT-4 pretty much has to like reason on its own whether it thinks, the article has high veracity. With fine-tuned GPT-4, we hope that when we fine-tune it, it sort of will on its own sort of learn like which sources are the most, provide the most signal on, what's going to happen in the future. As far as the Scratchpad goes, yeah, don't have one in this presentation, but happy to, it's there are some examples in the paper and happy to share with you some as well. But what we do is we filter the irrelevant articles and we don't feed that to the language model because, I mean, you could feed the irrelevant articles, but in that scenario, you'd be just taking up space in the context and potentially confusing the model. So we just filter them beforehand. What we do is we just take all articles that have a relevancy rating higher than 4. How did we choose this? We just chose this by trying each threshold and see what gave the best performance. And it seems like, if from a scale of 1 to 6, if it was higher than 4, then it had some information that was like worth giving to the model.
Manually did that curation?
No, so we don't manually do the creation. Everything is automatic.
Mm.
But as far as choosing, like, okay, so basically the language model ranks every article that we retrieve on a scale of 1 to 6. Okay, now we have a set of articles that are all ranked on a scale of 1 to 6. The question now is which articles do we take? Do we take all articles with relevancy higher than 3? Do we take all articles with relevancy higher than 4? And we chose that we're going to keep all articles with relevancy higher than 4. And how did we make this decision? We made this decision by testing each hyperparameter and seeing which one was the strongest.
I'm just wondering, how we can make sure that model really filters out those fake news, right? Fake information and really sticks to like proven original source for its prediction, because it would be really easy to mislead the prediction, right? And like
Right,
intentionally manipulate the intention
right.
through those fake news.
Yeah, absolutely. Interesting question. I think it's definitely possible for this to happen. I think, if you're continuously, fine-tuning your model, then you can imagine that it'll learn like what are the so let's say there's some news source that's uploading like, fake AI articles, and like these articles can fool your model. Well, if you're continuously training your model, let's say every month or so, it's going to learn that these new sources that just popped up in the past month are like not good and not predictive of the actual outcome. And I mean, the other thing you can do is just have like a list of trusted sources. So you can imagine collecting a list of like 100 news publishers you trust, like New York Times, Washington Post, etc., and saying like, okay, I only want you to consider articles from these sources. And we did actually block some sources because they were just really bad. So it's like, okay, we're not even going to waste that time. We're just going to like, not retrieve any articles like from these sources.
Jim, I see your questions. Do you want me to read them?
I can elaborate if you want.
Sure.
So is is the crowd prediction part of the prompt?
Yeah, it's a great question. It's not.
Oh, good, good. How do you prevent leaks from news retrieval? Like if there's an article
Right.
that has been updated but still has the original dateline?
Very good question. Yeah, so what we did is we took like a bunch of questions, we retrieved articles, we went through all of them, and then we like saw which news sources do update their articles. And if they do update their articles, we added them to some list, which in this list is a list of sources where we never retrieve articles from. And we just iterated on this process until we only kept sources that don't update their original articles. So that's how we prevented that. It's not perfect, but in the final analysis, when we tested it at the end, like we saw that like less than 0.5% of articles get updated.
In exceptional cases, some of the major news outlets, I think most of them will update, but I think they usually have a date. The more reputable sources, larger newspapers and such, will put a date on their website for the date of the update. So I imagine that's feasible to
Right.
screen separately from
Yes.
the list of like.
Or sorry, just to touch on that, that's exactly right. So if they do update their content, but they post an updated date, then we kept them as a source. We only remove sources that update their articles but don't put an updated date, is what I meant to say.
Okay, my last question is in the forecasting literature, people love back testing for financial markets of various sorts. And I'm wondering if you've considered using metrics from that discipline, such as the Sharpe Index, for a betting strategy and to compare. Have you done any work on that kind of thing?
No, we haven't. Yeah, not too familiar with Sharpe Index or back testing metrics, but yeah, that's an interesting idea. Would be curious to look more into it later.
I'm wondering, like, what are the sort of next steps for this research work? What are you guys thinking?
Well, I think the next step is to see if we can get this to be, more accurate than human in all cases. I mean, I think if this is possible, I think the implications are pretty significant. Uh, I mean, like currently, like for example, the government hires forecasters to predict a lot of things so that so that the government can make informed decisions. Now, the thing about these human forecasters is that they're very expensive and they're slow, and they have, specific expertise on very specific things. So if you have a system that has very uh, expansive knowledge across domains and that is cheap and that you can ask whenever you want throughout the day at any time, I mean, this technology would be extremely useful for policymakers, people in government, people in consulting firms, for business CEOs trying to figure out like where is technology going, what to invest in. So yeah, I mean, so currently I would say the system is not completely there yet. But I think that uh, any future endeavors to make it better would be really worthwhile if they could get it to work. And yeah, we're already aware of like a couple groups who are already very excited about this and who are working to make these systems better.